That's the plan.
Hi guys, welcome. Dean Chase here with another geometry lesson. Today we're going to be learning how to classify polygons. This is lesson 1.6, page 42 in your book if you're working with me in class. Let's go ahead and start with a word of prayer. Dear Father, I want to thank you for today. Thank you for the opportunity to teach. I pray that you'll be with my students, help them learn. Just help everybody have a good day, and thank you for all that you do in our lives. In Jesus' name we pray, amen. Alright guys, let's get started. Classifying polygons. First off, we gotta learn how to identify a polygon. In geometry, a figure that lies in a plane is called a plane figure. A polygon is a closed plane figure with the following properties. It is formed by three or more line segments called sides. Each side intersects exactly two sides, one at each endpoint, so that no two sides with a common endpoint are collinear. Each endpoint of a side is a vertex of the polygon. The plural of vertex is vertices. A polygon can be named by listing the vertices in consecutive order. For example, ABCDE and CDEAB are both correct names for the polygon at the right. Really important thing to note here is all they want you to do is list them. So if you start here, you got to go in that order. If you start here, you gotta go in that order. Easy enough. I personally prefer alphabetical order. If you're one of my students and you're doing worksheets, do it alphabetical order. It'll save you time. Make sure you get the right answers. Anyways, so now we're gonna learn about concave and convex. A polygon is convex if no two lines that contain a side of the polygon contains a point in the interior of the polygon. A polygon that is not convex is called non-convex, or the term we use is concave. So all that is saying is if you were to draw a line on each side of this polygon, if it never extends through it, it's convex. Here they show you if you draw a line along this side of this polygon, it cuts through. So that's a concave polygon. The way I like to remember is concave, you think about it like this. It's like going into a cave entrance. Like, it looks like a cave entrance, whatever. Just how I like to remember it. Probably makes no sense, but that's how I like to remember it. So example 1. Tell whether the figure is a polygon. If it is, tell whether it is convex or concave. Well, a star is a polygon, and it is concave. Okay? Because if you were to draw a line along this line, it cuts through. Okay? A circle is not a polygon. It does not have three sides, okay? This is a polygon, and it is convex, okay? And lastly, a triangle is a polygon, and it's also convex, okay? These don't have any points that are dipping into the polygon, okay? This one, concave. Okay, pretty basic. Hope that made sense. Classifying polygons. A polygon is named by the number of its sides. So let's just go ahead and read through the list. Number of sides: 3 is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nongon, 10 is a decagon, 12 is a dodecagon, and for any number of sides you called it n-gon. Most of the time in your homework, you'll be using their names up through 12, and then anything after that you called it n-gon. Because the term n-gon, where n is the number of a polygon sides, can also be used to name a polygon. For example, a polygon with 14 sides, you could just call that a 14-gon. If you Google like polygon names though, they go for a long time, forever and forever. Like, it's awesome. Some of the unique names they have. So now we're going to learn about equilateral and equiangular triangles, okay? Or not triangles, polygons, sorry. In an equilateral polygon, all sides are congruent. So all the sides are going to be the same. So like this here, each of them have one hash mark, meaning all the sides are the same. In an equiangular polygon, all the angles in the interior of the polygon are congruent. So if you see, each of these have one arch in the angles, so they are congruent. A regular polygon is a convex polygon that is both equilateral and equiangular. Okay? So, example 2. Classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. Explain your reasoning. So, first off, this has 3 sides, so it's a triangle. Okay? And it is neither equilateral or equiangular. So, not equilateral or and the reason why is because not all sides or angles, angles are congruent. Okay? The next one we have, let's count the sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. So it's an octagon. And it's a regular octagon. Regular. Because all sides and angles are congruent. All the angles are marked with one arch, and all the sides are marked with one hash mark, so they're all congruent. Next, we have this 4-sided figure, which is called a quadrilateral, which, forgive me if I misspell it. I won't, though, because I have it written down. So, a confession to make to all you guys watching this, terrible speller. So, as we go through this journey together, you may see me misspell things. I apologize. Definitely a math teacher, not a spelling teacher, English teacher, whatever. So this quadrilateral, all 4 sides are congruent, so it is equilateral. But not all 4 angles are congruent, because this angle is congruent to this angle, and this angle is congruent to this angle, but not all 4 are congruent to each other. So, not equiangular. Because all sides are congruent, but not all angles are congruent. Okay? Hope that makes sense. Not a bad example. Let's just keep going. So example 3. A rack of billiard balls is shaped like an equilateral triangle. Find the length of a side. So the first thing we need to recognize is that it's shaped like an equilateral triangle, meaning all 3 sides of that triangle are going to be congruent, which means we can solve this just by setting those equal to each other. So we can do 6x minus 4 equals 4x plus 2. So to solve this, let's subtract 4x from each side, and let's add 4 to each side. Okay? The 4x's cancel out, and the 4's cancel out. So we're going to be left with 2x equals 6. Divide each side by 2. X equals 3. Okay. Now we're not done there because they want to know what the length of one of the sides is. So we need to take this 3 and we can plug it into any one of these equations. I'm just going to plug it into the one closest. So we know that 4 times 3 plus 2 is going to be the length of one of the sides. Well, actually all of the sides. So 12 plus 2 14 inches is what all the sides will equal. And that's going to be true here. If we would have done 6 times 3 is 18 minus 4 gives you 14. So all the sides are going to be 14 inches. That's all, folks. Pretty simple lesson. Not too bad. Hope it made sense. Hope I did a good job explaining it. If you need anything, let me know. Other than that, see ya!